Hello and welcome back to another LeetCode video. Today we're looking at LeetCode 3697, Compute Decimal Representation. It's an easy problem and we're going to use it for interview practice as we usually do. So let's get into it. So we're given a positive integer n, and a positive integer is a base 10 component if it is the product of a single digit from 1 to 9 and a non-negative power of 10. For example, 530 and 7 are base 10 components, while 537, 102, and 11 are not. Express n as the sum of only base 10 components using the fewest base 10 components possible. Return an array containing these base 10 components in descending order. Interesting. So we give it a number n. The first thing I would want to know from the interviewer is, well, what values can n have? Well, it's already written here that's going to be positive, but I also want to know whether it's going to be 0 or not. In the constraints, it will tell us it's at least 1. Nice. Now, we also need to, we now need to ask for some examples to maybe understand, what the output exactly looks like and how the mechanics of computing those base 10 components work. And one thing you can do is you can always ask the interviewer for examples, or you can come up with some of your own if they don't provide for you. Now, the example from the problem description is where n is 537, right? And we decompose it into 530 and 7. So their sum is the resulting variable. However, the base components are strictly divisible by a power of 10 without any rest, right? So 7 is divisible by 10 to the power of 0, which is 1. 30 is divisible by 10 to the power of 1, which is 10. So 30 by 10 is 3. And 500 can be divided by 10 to the power of 2. So 10 squared, which is 100. So 500 divided by 100 is 5. Right. And it's impossible to express the number as a sum of fewer components using fewer than 3 base 10 components. Yeah. I mean, yeah, that makes sense. So we always try, like if we have 100 in here, we try to turn that into one component. If we have tens place, we have to try to turn that into a tens component, etc. Now, second example, n is 102. So here the result would be, I guess, 102. Those would be our two components. And they actually are. Now with n 6, we only have one component, and that is the one with the value 6. 10 is a base 10 component because, 6 is a base 2 component because it's divisible by 10 to the power, raised to the 0th power. Okay, so in terms of approach, I think what we can do is we can iterate over the, yeah, we could iterate over the digits, right? And we could increase, let me think about this. So if we iterate over the digits of n, so what we could do is we could start with something like this. Let's say comment code in here. So if we start with 537, we could easily extract the last number. So this is our number n. And we could extract the last digit using n modulo 10, sorry, because we're base 10. And if we do that, we get back the 7. Now, if we then divide n by 10, that means shifting it by one decimal place. So that would become 53. Now, if we perform the same action on 53, we could extract the 3. And we get 5 as the next value for n. And then that's 5. And then we reach 0. And that's basically the end of our algorithm. So I think we need some logic to extract always the last digit. And I think we could do that this way. And you can see that we're extracting them in order of, I suppose, least significance. First the last digit, then the next one. So what if we, at the same time, so if we called this our digit, now what if we did digit times equals 10 to raise to some power I, right? Well, if we took the 7 and raised that to, well, to turn it into a component, right? That's what we want to have. Base 10 component. Well, so 7, we know that 7 should be multiplied with 10 raised to the 0th power. So we should have 10 times 7 times 10 raised to 0. We know that the 3, we would have to raise it to 10. We have to multiply it with 10 raised to the first power. And with the 5, we know that we have to raise it to the second power. So what we could actually do is we could, as we iterate to extract the least significant digit of the remainder of what we have of n, we could multiply that digit with 10 raised to the power of a variable that we keep track of, how many iterations we have in our loop. I think now we actually have built all of the 3 components, and we just need to put them into an array. So that would be my approach, to decompose the number into digits and at the same time multiply them with powers of 10 to get actually the base 10 components. And then in the end, we just return them. Excuse me. Right, so that's what we're going to do now. So digits, maybe result. And in terms of runtime complexity, so just iterate over all of the digits in n. So that would be O of n, well, of log n, right? And base complexity, the same. Except that we have log n elements of length log n. So, but it's still log n, so that'll be, I guess, 2 log n or something. So I guess it doesn't change really anything in terms of runtime and space complexity. So let's just go with that. So we start with our little factor. The factor is going to be this multiplier here. And in the beginning, we started with 1. Now we need to iterate until n becomes 0, because we know n is a positive number. So it's not negative, so we can just do while n. Now let's extract the digit. Well, that's n modulo 10. Now, if we have a digit, we need to append it to a result. Otherwise, if we have here in this example 102, one digit would be 0, but we don't want to add it as a component because 0 is not, a component that we need in order to rebuild the number 102 when we sum them up together again. So if digit, we do result.append factor times digit. And now we just divide our value n by 10. So that's going to be the integer division, this step here. And we're also going to increase our factor. So instead of having index I, we just keep track of a factor. And in the beginning it's 1, then becomes 10, and then becomes 100, which is exactly what we had here. We have 10 raised to the ith power. Cool. So I think that would be everything that we really need for this. And we could make this a little bit more concise, I guess. We could just say the component is always going to be factor times digit. No? And then we say if component, we're going to append the component to our result. What is that? Oh, there's one more thing that I just overlooked. So the order in which we put the components in here is, of course, now the reverse order. Because first we put in the 7, then we put in the 30, then we put in the 500. But we want it in reverse order. So we have to actually reverse the result before we return it, right? So I'm kind of happy with that. I would now run it through the test cases just to make sure that the tests pass in an interview. You either have the ability to write your own test, or what you can do is you can also, ask well, you can ask whether you can get some test code, you can implement it yourself, or you can step through the code with a mental debugger with one of the examples that from earlier. You just step through it manually. All of those are valid approaches, and just clarify with the interview what you want. Right, so now let's submit it to see if it passes all of the test cases. And it most certainly does. So yeah, awesome. That's that.